Good day everyone. In properties of definite integrals, the first property we saw was integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Since we used that in many sums, that was the first property I first explained and we have done some sums. But actually, that is a special case of this property, that is integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. When the lower limit becomes 0, that is a special case, no? Then you get this property. So let us see how we are going to use this one now. You consider the sum integral 1 to 2 root x by root 3 minus x plus root x dx. In this sum the limits are 1 and 2. A is 1 and B is 2. What is A plus B? A plus B is 3. A plus B minus x is 3 minus x. So, if you look at the terms, you have a 3 minus x, you have x. So, it looks like you can use this property and you will be able to arrive at the result. Okay. So, now I call this as I, that is equal to, I call this 1. Now, I am going to use this property. So, now I will get I is equal to, wherever x is there, you have to put now 3 minus x because that is your a plus b minus x. So, the numerator that will become now root 3 minus x. Here you will get 3 minus x plus this x will become 3 minus x dx, right? Let us simplify it. Now, let me write the numerator as it is. In the denominator, in the first term, the plus 3 and minus 3 will get cancelled. You will get x. So, you will get just an x there. Plus the second term is root 3 minus x dx. Call this as 2. So, you remember what we did in those sums? We will add 1 and 2. Do the same thing here. You add 1 and 2. So, the left hand side, I plus I, you will get 2i. Okay. Then, let us come to the right hand side. The limit is 1 to 2. See the denominator? The same denominator. Only the terms are interchange, but there is a plus in between. So, no problem. So, let us write the denominator first. Root x plus root 3 minus x. See the numerator? Here you have root x. Here you have root 3 minus x dx. So, you get the same numerator and the denominator as same. Cut it. So, what will you get now? 1 to 2, just dx here. So, you will get x within the limits 1 to 2. So, you will be getting 2 minus 1, that is equal to 1. You have your 2i here, remember. So, your I will be equal to half. So, do you follow this sum? It is a very simple sum only. Only thing is, you have to see the a and b and check the terms so that you can apply that property. Now, I think we can see one more example, okay? Now, consider this example. You have integral pi by 6 to pi by 3, 1 by 1 plus root cot x dx. Okay, let us call this as I. I is equal to. Now, first, before proceeding to the sum, generally, whatever is given in tan or cot, we will be converting in terms of sine and cos. So, let us write root cot x as root cos x by root sine x. So, I will be getting pi by 6 to pi by 3, 1 by 1 plus root cos x by root sin x dx. We can take LCM here and this root sin x will go up. So, we will be getting pi by 6 to pi by 3. You will get root sin x here. In the denominator, you will get root sin x plus root cos x dx. Now, call this as 1 now. After simplifying, that is after bringing it in terms of sine and cos, call that I as 1 now. Now, you know your a is pi by 6, b is pi by 3. What is a plus b? Pi by 6 plus pi by 3 is pi by 2. So, a plus b minus x will be pi by 2 minus x. You know sin pi by 2 minus x will be cos x. Cos pi by 2 minus x will be sin x. So, now we will use that property and then we will write I again. So, we will get pi by 6 to pi by 3. Now, in the numerator, you will get sin pi by 6 plus pi by 3. I know it is already pi by 2. So, I will write it. In the denominator, here I will get sin pi by 2 minus x. Plus the next term will become cos root cos pi by 2 minus x dx. So now we will be getting pi by 6 to pi by 3. The numerator will become now root cos x by the denominator. The first part will become root cos x. The second part will become root sin x dx. Call this as 2. Okay. So after applying the property, now wherever we got root sin x, that became root cos x, and wherever we got root cos x, that became root sin x. Now let us add 1 and 2 as usual. Add 1 and 2. Now you get 2i, that is equal to integral pi by 6 to pi by 3. See, the denominator is same, so we will write root sin x plus root cos x. Numerator, in the first one you have root sin x, in the second one you have root cos x dx. So normally in these terms you will get them same only, so they will get cut. So you are going to get here only integral pi by 6 to pi by 3 dx. So that will be x within pi by 6 to pi by 3. So you will get here pi by 3 minus pi by 6. Okay, so you will get only pi by 6. 2i is pi by 6. So I will become pi by 12. So do you understand these two example sums? So now we can go for another property now. Now the property is integral minus a to a f of x dx is equal to twice integral 0 to a f of x dx if f is even. It is equal to 0 if f is odd. So far you have got only one result. Now for this left hand side there are two categories, or there are two answers. If your f is an even function, you get twice integral 0 to a f of x dx. If f is an odd function, you get 0 as the answer. So before proceeding to this property, you should know what is an even function and what is an odd function. Let me explain that to you. That is, if f of minus x is equal to f of x, f is even. Okay. If f of minus x is equal to minus of f of x, f is odd. This is the definition of odd function and even functions. Let me give you some simple examples. First, let us consider some simple algebraic expressions. Right? Now I will consider x squared, x power 4, x power 6, x power 8, like that. That is, I am considering all the powers to be even numbers. Now let me take one thing. If I take my f of x is equal to x power 4, let me find out what is my f of minus x. In the place of x, I have to put minus x. So I will get minus x whole power 4. Because you have a power 4, the minus will become plus. So you will get x power 4. Then your f of minus x is equal to f of x. So now here your f of x, that is that x power 4, is an even function, right? So all these things, wherever you have the power as even, you will get that f as an even function, right? Now let us consider x cube, x power 5, etc., where your powers are odd, right? Now let me take f of x is equal to x cube. Now f of minus x will be minus x the whole cube. Since the power is odd, the minus will be minus only. You know that, no? Minus into minus means plus. Then if another minus, you will get a minus. So now you will get here minus x cube. So f of minus x is equal to minus of f of x. So now x cube, x power 5, like this, where the power is odd, those functions are called odd function. Okay, so this is as far as algebraic functions are concerned. Now let us see some trigonometric functions. You should know them also. If you consider cos x and secant x, they will be even function, because you know cos of minus x is equal to cos x. Similarly, secant of minus x is equal to secant x, because in the fourth quadrant, cos and secant will be positive. So these two are called even functions. Okay. The other four, that is sin x. Then you will have tan x. you will have cot x, you will have cosecant x. They are all called odd functions. But supposing you have sine squared x, even though sin x is an odd function, because you have a power 2, that is an even power, no. So that will become an even function. So these are all the preliminary things you should know about odd and even functions. Then only we can go into the formula and how that property we apply to the sums. Now let us take one example sum. I have given minus pi by 4 to pi by 4 x cube sine power 4x dx. Here the f of x consists of a product of two terms, that is x cube into sine power 4x. When I see this sum, the limit in the lower limit and upper limit, the pi by 4 only I am having, but I have a minus here, I have a plus. So this property I have to try whether it will apply and how I can go about it. So I am writing my f of x. Now I will find f of minus x. So here minus x the whole cube sine power 4 into minus x. Here this will become minus x cube. Because I have a power 4, this will become sine power 4x. So my f of minus x becomes minus of f of x. You have to show this working. So now I have proved my f of minus x is minus of f of x. So I will write f of x is an odd function, right? F of x is an odd function. So I is equal to 0. That's all. Straight away we will be getting the answer. So when you see the limits as the same number, only the signs are different. That is a minus in the lower limit and a plus in the upper limit. Then you have to check whether the f of x is either an odd function or an even function. If it is odd, you are straight away writing it as 0. So the answer is 0. Are you clear about this example? Let us see another example. I is equal to integral minus pi by 4 to pi by 4 cos x dx. Here also it is of that format minus a to a. Now what is your f of x? Your f of x is equal to cos x. So you know f of minus x is equal to cos of minus x, which is equal to cos x. So f of minus x is equal to f of x. So you know f is an even function, right? So when f is an even function, now we have to apply this formula. So you will get now I is equal to twice integral 0 to pi by 4 cos x dx, right? So now cos x you have to integrate. What is the integration of cos x? That will be sin x. You have a 2, write it here, 0 to pi by 4. So now you will get 2 into sin pi by 4 minus sin 0. Sin pi by 4 is 1 by root 2. So 2 into 1 by root 2. Sin 0 is 0. So you will get here root 2. So root 2 is the answer. So do you understand how to use this property? So today we have seen two properties. One is integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. Okay. Then second one is integral minus a to a f of x dx is equal to twice integral 0 to a f of x dx if f is an even function. It is equal to 0 if f is an odd function. Remember what is an odd function, what is an even function. Let us see some more examples in the next video. Thanks for watching the video. You can subscribe to the channel and click the bell icon so that you will get notifications of further videos.